So today we're going to look at solving polynomial equations. We did this in chapter 5. We solved quadratic equations. We solved quadratic equations by factoring, quadratic formula, completing the square, all that good stuff. So remember, when we were solving quadratic equations, we normally just factored it and found the answers, or we graphed it. In this case, we're going to get cubic functions, which you don't necessarily know how to factor yet. So you can actually solve a polynomial by graphing each side of the equation separately and finding the x values of the points of intersection. This is one method. I'm also going to show another method. Okay, so if you're going to choose this method, you will type one side of the equation. So you can see here's my equation. Solve x cubed plus 3x squared equals x plus 3. You'll type the one side of the equation into your y1. You'll type the other side of the equation into our y2. Don't type this one in right now because it's actually already solved for us. You can look at the pictures. We'll do the next one on our calculators. But write this down in your notes. So we would have the left side, doesn't matter which side I guess, but one of the sides will go in your y1. One of the sides will go in your y2. And you'll graph it. Here's what the graph will look like. You'll have two curves or two lines, or a curve and a line. Now what you're looking for, if you choose to do this method, is you're looking for when are these two things equal, which means you're looking for the points of intersection. So to find the intersections, which would be here, here, and here, you might want to put that in on your notes. Go ahead and draw some dots though. Those are your answers to the equation. Now we've used the second trace button a ton of times. So when you press second trace, we've done the 0, we've done the minimum, we've done the maximum. We have not done the intersect, I don't think. So yes we did. Yes we did. Back in chapter, I think 2, when we did linear systems and we graphed them, we would graph one line, graph the other line, and do intersect. Okay? So that's what we're going to be doing. We're going to be choosing the intersect feature. And again, don't type this one in your calculator. We'll do the example below. But you can see they found this intersection point is -3. This intersection point is -1. And this last intersection point is 1. You disregard the y values. You're only looking at the x values to get your answers for the values of x that would make the equation equal. And then it says you can also check the solution by taking those answers and plugging them back in, which I'm not going to require you to do, but you can check it by plugging them in. All right, so this is the equation we're going to do together. Solve the polynomial equation by graphing each side of the equation separately and finding the x values for the point of intersection. Use your graphing calculator. Okay, so this will go into our y1, and this will go into our y2. Oops. Now I already have mine typed in. So in y1 we'll put x cubed minus x squared, and in y2 we'll put minus 2x squared. And then we of course want to reset our graph to be like a normal zoom 6. And if you want, you could even sketch this down on your notes just to like have an idea for when you look back at your notes and you're trying to figure out how you did this problem. Something like that. So there's actually only one point of intersection this time. So we're going to press second trace, and we're going to choose intersection. Option 5. Now it will ask you questions. Remember how we used to do left bound, right bound, and guess for the zeros and the maxes and the mins. This one's going to say first curve question mark. It does not matter what curve you're on, if it's actually y1 or y2. But just whenever, after you hit enter, you do want to make sure that it jumps to the other line or curve when it says second curve. Hit enter. And then you will guess and get as close as you can to that intersection point. And we should get -1, -3. Remember, the answer is only the x value. So your answer is x equals -1. That's your final answer. Now, before we move on and do another one, I did want to show you the other option, okay, method 2. Method 1 is, of course, graphing both, looking at the intersection point. Method 2, we actually did in chapter 5, and that would be to get the equation set equal to 0. So actually use inverse operations. And then graph it, but find the zeros instead of the intersections. This is going to get you the same answer, so I don't really care which one you do. I'd like to show both, but you can do either. Some students like doing the intersection point better because it's just first curve, second curve, guess, instead of having to do left bound, right bound, guess, left bound, right bound, guess, left bound, right bound, guess. But this one's, and I'll show this one. So if we were to use inverse operations, we would add 3 to both sides. So we get x cubed minus 2x squared plus 3 equals 0. So let's go back to our y equals. Clear out both equations, because this time if you choose method 2, you're only going to type one of the equations in, which is what's on and we would choose Zoom 6. You'll only get one curve if you choose method 2, because you actually set it equal to 0. You don't have 2 equations, you just have 1. And you're looking for the 0. So you would press second trace, option 2 for 0. And then we would have to do our left bound, our right bound, and our guess. And you'll get the same answer. Now, you will get a different y value because we've modified the curve, but remember, the answer is just the x value, so it doesn't matter. Anyone having trouble with either of the methods that needs to be comfortable with their calculator? So I'm choosing method 1 just because that's what the lesson was really about today. But method 2 is a review of something we've done before. Now sometimes you will have to modify your window, right? Sometimes you can't see really what's going on. Like this one isn't the best. So I would probably want to adjust my window. So it looks like I can see everything on the x-axis pretty well, like I can see everything here, but I need to see higher up on the y-axis and I need to see lower down on the y-axis. So let's press the window. Let's change our y-min, and again, this is completely a guess. I have no idea what I'm doing. I'm just going to press a number that's smaller than -10 and a number that's bigger than +10. Let's try -20 and +20. For my y-min, -20, y-max 20. Press graph. Still can't fully see what's going on down here. Okay, I can see 1 point intersection there, 1 point of intersection here, but I'm thinking there might be a third one down at the bottom corner. So let's go back to window, and let's just change it to something more drastic so I don't have to come back to the screen. So let's go -50, +50. And then that one, we should be able to see 3 points of intersection. And if you want, you can kind of sketch this on your notes, just so that, again, you have an idea of, that's one of my curves, and the other one. So you're looking for, this time we'll have 3 points of intersection. So we'll do second trace. Intersection, you're going to have to do this 3 times, 1 for each point of intersection. So first curve, enter, second curve, it automatically jumps there, hit enter, and then I would go over and just go from left to right. So I'm going to go to find this one first. That's why this guess feature exists, because if you just press first curve, second curve, they don't know which of the three you're looking for. So you do want to make sure your guess is pretty close. And I should get -5 as one of my answers. Second trace again, option 5 for intersect. First curve, second curve. Again, you don't have to pay attention to first curve, second curve. You literally can just hit enter. If we were to have 3 curves, then you'd have to really pay attention to which 2 you were talking about. But since we only have 2, it doesn't matter. The guess is really important. We should get -1. And then do it all over again. Oops, first curve, second curve. Yes. Fourth. So those would be my 3 answers. If you chose method 2, again, you would have added 2x squared and subtracted 20, and then graphed that and found the zeros. There would be 3 zeros for you to find. All right, number 3, and if we don't get to 4, that's okay, because there aren't any like this in your homework. This one's a little bit more challenging, but we can at least talk about it. If we have time, we will. All right, so the next one, word problems. We all know you love them, love to hate them. They're going to be coming up on your next quiz, I promise. So, all of them are pretty much volume related though, length times width times height. So the volume in feet of a cubicle area inside a doghouse can be expressed with the width as x, the length, x plus 4, and the height, x minus 3. So normally that's all we've been given, or we're asked to find it. They also tell us what the volume is. In any of the other problems, they just told us the function for volume. This time they're actually telling you that the volume is 15.9 cubic feet. Find the dimensions inside of the doghouse. So we know volume equals length times width times height. And we're going to substitute in what we know. The volume is 15.9, so that's going to go in on the left. The length, we'll put parentheses around it, x plus 4. The width is just x, which I also will put parentheses around just because it's in the middle and it looks weird not to have them. And the height is x minus 3. And then we're going to find the values of x that would hold true for this. So you have method 1, which is to graph this side of the equation in your y1, and graph this side of the equation in the y2. You also have method 2, which would be to subtract 15.9, and then find the zeros. Okay, but I'm going to do it this way. Go to our y equals. You do not have to FOIL all this stuff. You can leave it as parentheses, but type it in. Oops. Do not put 15.9 cubed, by the way. Remember that that's just a unit. You're only putting in the actual number. And then we'll start with Zoom 6 and see what we get. Although I can already tell you that's not going to work because 15.9 is bigger than 10 and Zoom 6 ends at 10 on the y-axis. So just giving you an idea, I know I'm going to have to modify my window just by... So you're only going to see the one curve right now. And that's again because this is 10. 15.9 is somewhere up here. So we got to change the window. We really probably just need to change our y max. I know I at least need to get to 15, so why don't we just make it like 20 or 30, and that way we can see high up. So I'm going to go change my y max to be, say, 30. 20 probably would have been fine, but that way I can give myself a little space. And we have to find all 3 zeros. Now, majority of the time, the final answer is going to be the positive value. But you have to be careful because if these were all x, x plus something, you can have a negative value of x because when you sub it in, it's still going to get you positive length, width, and height. So really, you should find all 3. So second, trace, intersect, first curve, second curve, and then I'll guess the one all the way on the left. And let's just go ahead and round to the nearest tenth. So negative 3.2. Do the other one, second trace, intersect. First curve, second curve. Guess. Negative 1.4. And then do your last one, second trace. Option 5. This one kind of skips around, so just get as close as you can. And we should get 3.6. Again, do not eliminate the negative answers because they're negative. Take them and plug them back in and see if any of them cannot exist. So negative 3.2 minus 3 would get me a negative 6.2. So that one is going to be eliminated. Okay, the negative 1.4 minus 3 would get me a negative 4.4. So that one's out. But it's not out because it's negative. It's out because when you substitute it back into one of them, it can't be negative. But I will tell you that sometimes you can get a negative value if these were all like x plus 1, x plus 2, x plus 3 or something. When you plug it in, it could be negative. So the answer is going to be our 3.6. Now, they do want the final dimension. So you actually need to take that and sub it back in to find out what the length, width, and height are. I'm just going to put a box over here because I'm going to write out. Okay, so we should get length is x plus 4, so 3.6 plus 4, which will be 7.6 feet. Width is just x, so that's just 3.6 feet. And height would be 0.6. 3.6 minus 3, 0.6. Now, some students will then say, Mrs. Bennett, I checked my answer. So if you were to go and actually multiply those together, you don't get 15.9. Why? Okay. They're rounded. So we rounded this answer, which then rounded all the other answers. So your final answer is not going to be perfect because you are rounding, but as long as it's close, that you'll know that you probably got it right. Okay, so just be aware of that. It will, when you round answers, you're changing your final answer as well. Okay. I'm going to skip 4. See if you guys can do the closure real quick, practicing that either by using method 1 or method 2. So those are the 3 answers you should be getting. So the homework is again on Google Classroom. I'll pull that up right now so that you guys can work on it for the last few minutes if you want to start. It's not many questions.